Now recording.
Thanks.
We're talking about our review today, and it was a question about amplitude and so forth. And we went back to a basic example, which was from college algebra. And we talked about how we identify H as 1, A is 2, and K is 3. I'd moved to the right one. I became skinnier. Then I moved the whole thing up 3. And then jumping over to Trig, we built on that. Again, we had similar layout, but this time one of the things we had to remember was to factor out that B. Okay, couldn't be part of that. This had to be in parentheses. So now the H is 1. That's my horizontal shift. The B is 3, which changes my period to 2 pi over 3. The amplitude is 2. And then the vertical shift, I'd move the whole thing up is 2. And then we would go about graphing that. Does that help, Johnny? I think you had the question.
Yep, thank you.
That's what you were looking for. Yeah, and I think we had assignment number 2 or 3 was really a lot about this, and another thing to look at. All right. I'm here for another whatever minute, 65 minutes. If anybody has questions. Old test, something you got wrong, something new you don't know. So many quiet people.
I mean, I could ask another one really
Go
quick.
ahead. Go ahead.
All right.
Time to look back.
Yeah.
Go ahead.
Can we go over just positional vectors one more time? The other day I kind of got confused on that one too.
Sure. Give me 2 points. An initial point. Just pick it.
Okay.
Go ahead. What is it?
5 and 7.
5, 7. Give me a terminal point.
-2, 3.
Okay, so that's a vector. I'm going to put it on the Cartesian coordinate system 1, 2, 3, 4. And as I've said over and over and over and over this course, draw the picture. Your picture doesn't have to be super pretty. Normally mine weren't. 1, 2, 3, 4, 5. And then up from up there, oh, well, 1, 2, 3, 4, 5, 6, 7. So we're at 5, 7. So that's my initial point, and -2, +3 is my terminal point. So the vector you just described looks like that. Now, positional vector is one that's going to take this point and move it down. And I still want to have the same turn, the same angle when I move it down, and I want to have the same length. So to find that positional vector, it's pick this guy up, move it, and put it down. So there's lots of ways. You know, there's an algebraic way, but the other thing is you can go in reverse. This is down from here. I'm going to move it over there. So I'm going to go down 7, and then I'm going to go left 5. That's going to move that to here. Well, if I move that guy down 7 and over 5, I need to move this guy down 7 and over 5. So right now this is at 3. So I need to go 1, 2, 3, down 7 is to here. It was at -2. It was at -2, but I need to go 5 more. 1, 2, 3, 4, 5. So I need to get over into here. And what's that new point? Again, I took the down 7, so my 3 now went down 7. So I did some algebra to get there. Okay, again, I could just count. You know, I went down 7, 1, 2, 3, 4, 5. So this has to be the point. The y value is -5, and I went left 5, I was at -2. So if I went left 5, 1, 2, 3, 4, 5, looks like I'd be at -7. Something along those lines. But I did draw sloppy, so let me double check. This guy went down 7 and over 5. So this guy that was at 3 went down. I'm sorry, that should be a 4. This guy was at 3. 1, 2, 3, 1, 2, 3. So he went down 7 to -4. My X value was at 2, but it got shifted left to 5. So what's the algebra in here? Terminal point 3 minus 7 for the Y value, -2 minus 5 for the X value. To me, I think it's a little easier to draw and count instead of trying to remember exactly what that is. But now this guy is the positional vector, -7, -4. And I can describe it just that way instead of describing it with 2 points. Does that help?
Yep, thank you.
Cool. I can flip the page. Second page. What you got? I'm thinking I should pause it until we get a question.
Going back to chapters 5 and 6, questions like solving the equation for the interval.
Go
So
ahead.
you would have like 2 sine squared x
2
equals sine x.
sine squared x equals sine of x.
Yeah, and it says solve the equation for the interval 0 and 2 pi.
Right. So that's between 0 and 360 degrees kind of deal.
Right.
All right. Let's see. I could divide by sine x, but I remember having conversation. If I do that, I lose an answer. So I'm going to get everything on one side. 2 sine squared of x. I'm going to subtract the sine of x equals 0. I'm going to factor out and get 2 sine x minus 1. And yeah, this is what would have been lost if we set it right away. So now I have the product rule, the 0 product. I can set the first one to 0 or the second one can equal 0. And this guy becomes the sine of x equals 1/2. So now I'm looking for answers. The sine, all of my ordered pairs are cosine sine. And if you remember, one of the things was if I looked at the unit circle, I can work with these a little bit easier. I mean, my other choice was to go, what's the sine curve look like? There it is. That's kind of easy too. When does the sine equal 0? At 0 degrees and at 180 degrees. There's 2 of the answers.
Awesome. Thank you.
Well, there's still more answers. I still have this sine of x equals 1/2. That goes
Right,
back to
right.
all whatever, all spiders taste crunchy. So I'm going to have an answer in the first and second quadrant. So now I'm thinking, all right, x is 1/2. So I'm going to draw this, and this is my theta, and the sine is 1 opposite over hypo. Oh, that's the square root of 3. There's another one. X equals 30 degrees. And over in this quadrant, 150 degrees. So all 4 of those answers would make this statement true. Now say okay.
Got it. Thank you.
Yeah. There and there.
So questions like this, you want to set it equal to 0 on one side, correct?
Yeah. Yeah.
Okay.
Almost always.
Professor,
Yep.
it's just I have a question about the assignment that we still have to submit. Can I ask one question of those?
We can try that. Yeah, and I'll do something similar or something to help you get started. What's the question?
It's number 5. It says a tree leans at an angle of 8.0 degrees from the vertical.
Okay, let me grab it. I have it right here, actually. You said number
5.
number 5. That's
Yeah,
on the
been
second
struggling with
page.
that one.
A tree leans at an angle of 8 degrees. Okay, so if the tree was straight up, instead it leans at an angle of 8 degrees. Right? That's what the picture looks like. Sound good so far?
Yes.
From a point 7 meters from the bottom of the tree. So if I go over here 7 meters, I see that it forms a 68-degree angle. I'm not recording this, by the way. Find the slanted height of the tree. So find the slanted height of the tree. That's this guy right here. Find that X. Well, it's not lost. It should say calculate. I don't know. All right. So if the tree was standing straight up, this guy right here would be a 90-degree angle. Well, it's not a 90-degree angle, is it? The answer is no, because it's this guy has to be 82 degrees. Okay, that guy has to be 82 degrees. So now, I can say, here's my triangle. This is X, this is 7, this is 82 degrees, this is 68 degrees. And you know how I am. I like to do A, B, C. Here's little a, here's little b, here's little c. I want to find little c. And it's right there. And I'm thinking, what do I have? Lots of different directions to go from here. Okay, I have big A is 82 degrees. And this is the version that really helps me when I write it like this. Big C is 68 degrees. Little a, I don't know. Little b, I don't know. Oh yeah, I do know, that's 7. And little c is what I'm trying to find. So when I look at that information, I go, if I only knew this b, I could use the law of sines. Okay, if I knew b, I would have my 4 pieces and I could find the law of sines. I could calculate what that little c is. Okay, I can come up with b, you can come up with b as well. The other thing is, I'm given an angle. Yeah, I think that might be the only way to do this. That's the best, because once I find that, then it'll help me calculate that, which would then help me calculate. So yeah, I think you need to calculate b, and then from there, use the law of sines. That's all I'm going to say about that.
So
Again,
I have one question too. So in the law of sines, A cannot equal C. It's only B can equal C, or?
well, in the law of sines, I need 4 pieces. Because remember, that was something along the lines of sine of A over little a equals sine of B over little b equals the sine of C over little c.
Yeah.
And I'm looking
So-
at B's and C's here, so I cross that out.
So like, can we find sine of C with using the sine of A,
Now,
or?
you need to use this proportion.
Okay, needs to be like that. All right.
Yep. So yeah, you need to come up with this, and a lot of you already have done it. That's 30 degrees. And now you have the sine of 30 over 7 equals the sine of 68 over C. Another thing, you could write it this way, because we know reciprocals come into play. That
Sounds
way,
good.
the mystery is up there. Go ahead.
Sounds good, I said.
I'm sorry, say again.
I said sounds good.
Okay, good. Shoot.
All right.
What else you got? In the online class, a couple students have already submitted theirs. It'll be good to help you to get ready for the final. Patrick, did you ever show up? He didn't show up. What else? If you have no questions, you don't have to hang around. This is just free time. Johnny, did you have a question?
Yeah, could we go over another one in chapter 6?
Go ahead. Go ahead.
So it was a word problem, says from a balloon 941 feet high, the angle of depression to the ranger headquarters is 58 degrees and 2 minutes. How far is the headquarters from a point on the ground directly below the balloon?
This is where people mess up a lot. The angle of depression means I'm looking straight ahead, and the angle is what goes down. Okay? The angle of depression goes down. If I'm standing here, the angle of elevation is what goes up. So if this goes down, if I know that this is 58 degrees, 2 minutes, then this guy right here has to be 90 degrees minus 58 degrees, 2 minutes. And then once you know this angle measure and you want to find this, you just say tangent of this equals x over 941.
Okay, got it.
So this really becomes what, like 31 degrees, 58 minutes. And you say something along the lines of tangent of 31 degrees, 58 minutes equals x over 941. 941, because it's the tangent, is opposite over. Remember, now we're back to working with right triangles. Woohoo! Bring that 941 over, type that bad boy into the calculator, and you should be able to find this distance.
Cool, thank you.
Mhm. That is kind of neat if you think about it, old school. You know, that you can figure out how far till you get to a certain spot if you knew how high you were. But you know what the problem is? What if you didn't have a calculator? What'd they do before calculators? Guess what? When I was in college, not college, in high school, we actually had to look in our book. In the back of the book was a table, and the table was the sine of, the cosine of, the tangent of, all different types of degrees, with degrees and minutes and so forth. So what you fire into your calculator in seconds, we had to look up in tables. Like we had to go and find a table for this to get that answer. I know I'm old, right? I forgot to turn the recording on. This was good stuff down here for me. We took care of the right side, changed tangent to sine and cosine, which made that sine squared over cosine squared. Multiply top and bottom by cosine to get a common denominator, put them together, and I know that cosine minus sine really is the cosine of 2x. I verified that identity. Again, the more you work with these identities in different ways, the more you pick up on when to use what, where, when, why, how, all of that. Do we have another one? Pretty good job. I mean, we're almost 45 minutes in. Ba-da-ba-ba-ba. Now I should pause the recording.
You do it one.
Yep. If I say 120 degrees is the bearing of 120 degrees. Everything I've done up to this point, I start here in this x-axis, but with bearings, we don't. We start facing north and turn clockwise. So a bearing of 120 degrees is going to take me to there. And if I had this, I would now be working with an angle of 30 degrees. My other bearing might be something along the lines of south 23 degrees west. And that's where I start, I head south, but then I turn towards the west 23 degrees. So that angle measure should be 23 degrees. Face north, turn clockwise. Otherwise, let the two directions dictate where I'm going. And say this ship went, 80 miles in this direction kind of deal. And this is 80. And then they turned at another bearing or over here. They wanted, so again, if I went 38 degrees, I would face north and I would turn 38 degrees so that the ship is now going this way. So all of these are based on where I'm at, face north and make a right-hand turn. If I got to this point and I said, now is on a bearing of 38 degrees, face north, turn 38 degrees and be going this way. Is that what you're looking for?
Yep. Thank you.
Yeah, I was on a boat 2 summers ago and I was watching all of this as it was happening with the bulb things on the dashboard and so on. And I'm thinking I should make a video of this and then I could, have it as part of an assignment. Oh, to have the time to do that. But imagine if you had video problems. Here's a problem and the boat's going and da-da-da-da, and you're looking at a video and you see it actually turn, and that would be kind of cool.